Assalamualaikum, hello and welcome to Gurukul Online Learning Network. Today I am your instructor Sheikh Mahadi. Our today's subject is Finance and Banking, Time Value of Money, Chapter 3. So today we will be learning about 4 topics of math. The formula of interest rate computation, EIR, annual rate, effective interest rate, Rule 72 and Rule 69. So let's begin with the interest rate computation. What will be the formula of the interest rate computation? Let's see. So it's I is equal to FB divided by PV to the power 1 divided by N minus 1. So as we know, FB stands for future value, PV for present value, and N for the number of years. So this is the basic formula of interest rate computation. So let's take a look at the example. Tanvir has BDT 1 lakh. He wants to keep his money in a double deposit scheme of Dhaka Bank Limited. With that scheme, the bank doubles his initials within 6 years. So he has a scheme that the bank will double his initial within 6 years, the 1 lakh taka. It will be 2 lakh within 2 years. Within 6 years, sorry, so double the amount. So Tanvi wants to know the implicit interest rate for that scheme. So basically we need to figure out the answer of the interest rate in which the scheme has given in 6 years, his given deposit amount will be double. So for that case, we have to use this formula. So let's put it down. So as we know, the future value, they said within 6 years it will be doubled. So the future value will be 2 lakh taka. That means 200,000. And the present value is 100,000. 1 divided by 6, the number of years. So 2 lakh divided by 1 lakh, that comes up to 2. To the power 1 divided by 6. 1 divided by 6, it comes to 1.16 minus 1. So 2 to the power 0.16, it comes up to a result of 1.117 minus 1. As we can see, if we minus 1.117 by 1, we get 0.117. So the initial, the most of the profit that you will be given is only 11%. So if we break down 11% down to the percentage level, it will bring down to 117. So that is the initial amount of interest Tanvir will be given in the duration of 6 years, in which his money will be doubled. So let's hop on to the EIR, effective interest rate. So what is effective interest rate? As earlier described, interest might be charged more than once in a year. This is a borrower that has to pay interest more than the started rate, in which in every step the amount of interest will be increasing. So it is necessary to determine the effective interest rate for a scheme. EIR is called effective interest rate, or the annual interest rate, or the interest actually paid or earned. So the basic formula of the EIR is so, as we all know, I is equal to interest rate, M is equal to compounding. Then let's take a look at an example. Mr. Anis wants to take a car loan from a bank. The bank authority that the interest rate for that loan has to be 16%. The compounded quarterly, 16% compounded quarterly, which means at the end of every 4 months. At the end of every 3 months. So that will bring down the quarterly to 4 months. You have to pay the interest 4 times in a year consecutively. Determine the actual interest rate that Mr. Anis has to pay for that car loan. So for that we need EIR, effective annual interest rate. So let's put it down. 1 plus I. The interest rate was given 16%. So if you break down the 16% to, it will be 0.16. And the compounding, what was the M? It was given compounded quarterly. So the value will be 4, which is given in every 3 months. So that will be 4. 3 4s are 12. 4 minus 1. 0.16 divided by 4, that will stand up to 0.04 to the power 4 minus 1. Let's see, 1 plus 0.04, 1.04. 1.04 to the power 4 minus 1. 1.04 to the power 4, that stands up to 1.169. 1.169 minus 1. So we will get the initial result of 169.169. So the effective annual interest rate for that loan is 16.99%. So if you multiply that by 100, we will get 16.99%. So that is the initial amount of loan that Mr. Anis has to pay for his car. So to the third topic, the rule now 72. So the rule 72, in order to determine the amount of time and rate required for doubling money quickly, can be used in rule 72. This provides a quick approximation of the interest rate of the number of years required to double one's money. So it is basically, it can be altered with the EIR formula, which is, they said, to double one's money, the approximation of doubling one's money, it's the time in which the approximate money will be doubled, within how many years. The rule 72 formula is easy. It is I is equal to 72 divided by N. So I is equal to 72 divided by N, that is the rule 72. It's named 72 for that. So let's take a look at the example. Determine the interest rate required for doubling BDT 1 lakh at the end of 6 years. Under the rule of 72, not EIR. If it was EIR, it would have been a different calculation. So let's convert the results with the conventional method. So it's simple, only I is equal to 72 divided by N. We have to decide the interest rate. N is equal to N stands for the number of years. So the number of years is given 6. So I is equal to 72 divided by 6, that comes down to 12. That means 12% interest for that 100,000 in 6 years to get double. This is easy as hell. It's one of the most easiest formula in the entire chapter. So let's take on the look to this rule 69. Rule 62, rule 69 and 72 are almost alike. So like rule 72, 69 is the technique of finding the number of years or interest rate to double the initial money. It provides slightly more calculation, a more required accurate rule of thumb. It is the rule 69. It's more accurate than the rule 72. So let's take a look at the formula. Formula of rule 69 is N is equal to 0.35 plus 69 divided by I. So let's take an example. Determine the interest rate required for doubling the deposit BDT 1 lakh at the end of 10 years under the rule of 69. So it can also be done by 72, rule 72, but if it's under the rule 69, it will be more accurate to the numbers or more accurate to the calculations. So let's see. I is equal to 69, all is given, it will be 0.35 plus 69 divided by I. Our I was given 10 years. At the end of 10 years, the which money will be doubled. So finally, if you do the calculation of that rule, it will bring it down to a similar 7.25 or 7.2% or just 7% annual interest rate within BDT 1 lakh at the end of 10 years. Within the interest rate of 7.2%, it will be doubled in the next 10 years. So however, we just learned the we have extra one more. It's called the perpetuity. The perpetuity. It's an annuity with an infinite life. It's called when we did the annuity due and the ordinary annuity, those both given interest at the end of a period or at the beginning of the period. Annuity due gave us the profit at the cash flow at the end of each period, and ordinary annuity gave the cash flow at the beginning of every period, which can be month, year, weeks, or even days. So it is then annuity with infinite life. Alternatively, an annuity that never stops providing its holder with cash flow at the end of each year. So let's take a look at the formula. So as we know, PV equals to present value, A is equal to annuity, and I is equal to the interest rate. So a given example 21, it's given what is the present value of perpetuity of taka 20,000 at 8% interest rate. So 20,000 8% interest rate cash flow at the end of each year. At the end of each year. Yes. So let's take a look at the math. So the interest was 8%. If we break it down to a percentage level, it will be 0.08. Divide 20,000 by 0.08, we will get 250,000. In here, it's called the annuity that never stops paying. So our interest rate was 8% and the initial deposit was 20,000. That never the present value of that perpetuity was 250,000. So these are the most common or the most easiest four formulas of the time value of money: the perpetuity of annuity, interest rate computation, EIR, rule 69 and rule 72. So that's all for today. If you have any kind of questions or comments regarding this session, please let us know down in the comment box below, and be with Gurukul. Thank you.